Good everyone, my name is Mr. Ademujimi Adedotun. What we'll be looking at is vector. What do we mean by vector? Vector are the quantities that have what? Magnitude and direction. I'll take that again. These are the quantities that have what? Both magnitude and direction. They have both magnitude and direction. They have both magnitude and direction, which can simply be defined as a vector, that is vector A. Vector A equals to magnitude of A and what? And direction. And direction. Can you see that? That's magnitude and what? And direction. Magnitude and what? And direction. When you have magnitude and direction, this is what we call vector. Example of this is what? When you have magnitude, okay, let's say for example of vector is what we call what we have torque. So is the word vector. We have what again? We have force. We have displacement. Displacement is an example of what? Of vector. Okay? We have another one again. We have acceleration. Acceleration is an example of this. Acceleration. And what again? We have force, we have torque, we have displacement, we have acceleration. We also have velocity. Velocity. These are what? The examples of what? Of vector what? Vector quantity. It means that since velocity is the word vector quantity, we can have velocity is a vector quantity, comma, acceleration is a vector quantity, displacement is a what? Vector quantity. So these are what? Are vector quantities. Why? Because they have what? They have magnitude and direction. So since they have magnitude and direction, they are known as what? As a vector quantity. So they are vector quantities because they have magnitude and what? And direction. Take notes. The one that does not have magnitude, that has only magnitude but not direction, they are what we call what? Scalar. Scalar quantities are what? The quantity that has what? Only magnitude but no direction. Example of that is when you talk about what? Distance, walk, and so on and so forth. They have only what? Magnitude, but direction is not what? There. Okay? Let's take for instance that we have 5 meter, okay? And we have another one here to be 5 meter per second east. What? Yes. Okay. 5 meter per second and 5 meter per second east. What can we differentiate between the two quantities that we have on the board? This shows that what this has only what? Magnitude. That is 5 meter. This is distance. Why 5 meter is talked about what? Velocity. This is distance. Distance. Why this is what? Displacement. When you say what? Displacement. Displacement means what? Distance moved in a what? In a specified what? Direction. The specified direction, that is displacement. Why do you say what? Distance is the gap between 2 points. Normally, distance has no definition, but in some textbooks you see it as gap between 2 points. But what do you mean by gap? Gap you talk about what? Distance. Okay? Distance. We have what? Energy. Yes, energy. Distance. Energy. Speed. Speed. This is what? Velocity. 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 Velocity is the rate of change of displacement, not rate of change of displacement with time. No. When you say rate talks about time. So there is no need of putting rate of change of displacement with time. Rate of change of displacement. This is rate of change of what? Of distance, okay? Rate of change of distance, rate of change of displacement. You can see that this is 5 meter per second east. So this is what? The direction. The direction tells us what? A boy walks 5 meter per second in east direction. So this is a what? A vector quantity. Velocity is a vector quantity. Why this speed only has what? Magnitude. Magnitude. But this has what? It has magnitude, and what? And direction. Magnitude and direction. Take note of that. Take note of that. When you talk about scalar, you should be able to differentiate between scalar and vector. Scalar quantities are what? Quantities that does not have what? Direction. They only have magnitude. They only have magnitude. While vector quantities has what? Has magnitude and direction. Examples are what? Acceleration, velocity, and what? Displacement. Once they are vector quantity, we can represent them by what? By this arrow. So let's look at that arrow. Let's look at that arrow. What's the meaning of that arrow? Say arrow. What's the meaning of it? When you see the word arrow in physics, we use arrow to what? To represent what? Vector. Arrow is used to what? To represent vector. Vector in physics. Okay? This is what we call what? Head of the arrow. That's the head. Head. Why this is called what? The tail. Tail. Why the what? The distance between this point and this point is what we call what? The magnitude. Magnitude. The magnitude, that's the distance between this tail and this head. This is the head. The distance is what we call what? Magnitude. Let's say for instance that this is vector A. Okay? So we can write this as vector A. You can see that. Vector A is equals to the magnitude of vector A and what? And the direction. And the direction. The direction. So the arrow is what? Head. Why this is what we call what? Tail. Tail of the vector. Head of the vector. Are we together? Okay. Let's move further. Let's say for instance that we have 3 kilograms of sugar plus 4 kilograms of sugar. Normally, if you have to add the two together, this will give us 7. Yes or no? Yes. 3 kilograms of sugar plus 4 kilograms of sugar will give 7 kilograms of sugar. Good. But normally, if you ask what to do this in a vector form, okay, we can say what? 3 units east plus what? Plus 4 units west, 4 units north, 4 units what? North. This is a vector quantity. You can say this is the magnitude. 3 is the magnitude. Why east is what? The direction. Okay? Why 4 is what? The magnitude. And what? And north is what? The direction. Okay, from here we can have this as 3 Newton. That's 3 units east. Of course, don't forget your 4 cardinal points. This is east, this is south, this is west, and this is what? North. Of course. So 3 units east. You can see that. And what? 4 units what? North. This is 4. Okay? Then what will be what? The resultant. The resultant of the forces will be what? A line drawn from where? From the tail. Of course, you know what tail is now. The tail of what? From the tail of the previous vector. The tail of the previous vector to the what? To the head of what? The second what? Vector. So this will be the resultant. The resultant. The resultant. So what will be the resultant? The resultant will be what? Will be 5. Yes. The resultant is 5. Take note. It's 5. It's 5. The resultant is 5. Because this is 3 and 4 triangle. We call it 3 and 4 triangle. So since it's 3, 4, this will be 5. 3, 4, 5. Or you can solve this using your Pythagoras theorem. You know, since this is the word due north is not directly what going to north. It means that what the angle here is what is 90. It's a right angle triangle. Okay, and using your Pythagoras theorem, that is e squared plus g squared. So that will be 16 plus 9. 16 plus 9 is 25. Okay, 4 raised to power 2 is 16. 3 raised to power 2 is 9. So 16 plus 9, that's 25. Square root of 25 is 5. Can you see now that this is equals to 5? Is equals to 5. And we have 3 kg plus 4 kg to give 7. To give 7 kg. Why 3 unit is plus 4 unit is not equals to 7. So it's equals to what? It's equals to 5. Okay? Now let's just take a look at this also. Whereby we have 3 meter east, 3 meter east 3 meter east, 3 meter west, 3 meter west, plus 3 meter east, plus what? Plus 3 meter north. Let's add this together. 3 meter east plus 3 meter west plus 3 meter east plus 3 meter north. Please, this is not equals to 9. Not equals to 9. You can't have this as 3 plus 3, 6 plus 6. No, 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 no. This is the word in vector quantity. In vector quantity. In vector quantity. Because we have the directions. You can see in the west direction. The other one is what? In the east direction. While the other one is what? In the north direction. So it's a vector quantity. Unlike this, that is just a what? A scalar. This is a scalar quantity. Okay? You can just say that what mass is a what? Is a scalar quantity. It has only magnitude, but no direction. It has no direction. Okay? This is a vector quantity. It's not equal to this. Why this plus this will be 3 meter west. That will be 3 meter what? West. That's west. 3 meter what? 3 meter west. 3 meter what? North. And this will be 3 meter east. Okay? 3 meter north. That's under 3 meter. Okay? And what? 3 meter east. That's 3 meter east. The one will be the resultant. The resultant is to draw a line, okay, joining the tail of the previous vector. Joining the what? The tail of the previous vector to the what? To the last vector. Tail to tail. Then to here. Okay? This will give us the what? The resultant. And what will be the resultant? The resultant is 3. Yes or no? Yes. The resultant is 3. The resultant is 3. You ask how come? How come? Why would the resultant be 3? Why not 9? The reason is this. This is equals to this. Why this is also equals to this. 3 meter, 3 meter, 3 meter. They are the same. 3 meter, 3 meter, 3 meter. This is perpendicular, 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 perpendicular. This is an example of what? Square. When you say square, all the 4 sides are what? Are equal. All the 4 sides are what? Are equal. So what will make this side to be 3? This is 3, this is 3. This we also do what? The 3 meter. Can you see that 3 meter west plus 3 meter north plus 3 meter east is equals to what? 3. That is what the beauty of what? Of vector. It has magnitude and direction. Okay? Now back to this. Back to this. Back to these 3 units and 4 units north. Okay? If you have this, let's take for instance that we have 3 units, 4 units west, that's 4, 4 west, and we have what? We have 3 what? 3 unit what? 3 unit west, 3 unit east, 3 unit west. What would this be? This will be 1. Yes. This will give you 1. Why? Because you can see, if you look at what the end of the 2 arrows, they are not facing the same direction. They are not. They are not in the same direction. You can see this one in what? In the east direction. Why this is in what? In the west direction. Not the same thing. So we can easily solve for what? For this. So that will be 4 minus 3. That gives 1. Okay. What can we deduce from there? We can deduce that. Same direction. Same direction. You subtract different direction. Different direction you have. Okay. This will be 3. No, this is 4. This is 4. This is 3 plus 6. That will give us 7. Meaning that what? From here to here is what? Is 7. Okay? But when you have something like this, this is 3 meter. Why this is what? This is 4 meter. Tail. This is 4 meter. The same direction, you what? You subtract. This is 4 meter. Okay? That will give us 1 meter. That's 3 minus 4 minus 3. That gives us 1. Take note. The same direction you subtract. Different direction you what? You add together. You add together. Different direction you add. Same direction you subtract. Different direction you add. Same direction you subtract. That is, if you have what? 3 units east and 4 units north. Different direction. Okay? When you have 3 units east, 3 units north. Okay? So let's go to addition. Addition of vector. Addition of vector. The first one there we have head to what? Head to tail. Head to tail method. Which is also known as polygon. Polygon law. Number 2 is what we call parallelogram law. 1, 2. The third one is what we call what? Triangle law. Okay? When you check your physics textbook very well, what you always see there will be this parallelogram law. You only see this parallelogram law. Okay? You only see the parallelogram law. This triangular is not there. Babu is not there. Head to head. We have head to head. No. Head to head is there, but they didn't call it head to head. They only use for the application, but it is called head to tail, not head to head. Head to tail, that is H to T. H represents what? Head. Thank God you know what head is now. When you have the word vector, this is what we call head of the vector. Why this is what we call tail? Please don't forget that. Head is what? The pointed what? Mouth. The pointed mouth. That's the head. Why this is the tail? Don't forget that, okay? Which is also known as polygon law. Polygon, that is when you have more than 2. Okay, that's the reason I call it what? Polygon. When you say poly means when you have more than what? Like more than 2. Like if you have 3 sides, something like this. Poly means many. When you have something like this, vector A, this is vector A, okay, vector A, and we also have vector what? Vector B, and we also have what? Vector what? Vector C, okay? Vector C, don't forget that this is a symbol to denote what? Vector. This is not just ordinary A. We call it vector A. This is not just the vector B. This is not just C, but vector what? Vector C. So if you have to represent this now using polygon law, so you can have what? This is always what? Vector A is. This is A. Okay? Vector B, this is always what? A. Why this is what? This is B. Why this is what? C. Take note. C, B, and A. Okay? So since A is always on like this, so that's A, then we have B, this will be B, right? And C is like this. So it comes like this, that's C. Okay? Can you see? That's what we call it what? Tail to what? Head to tail method. Head to tail. Head to what? To tail method. Head to tail. Head to tail method. Head to tail method. Look at the head of this arrow. Head of the first vector. That's the head of the previous vector. Joining with the one with the tail of the what? This second what? Vector. Why the what? The tail of the third vector joining with what? With the head of the second vector. Okay, from there, what will be the resultant? The resultant will be from here to here. Okay, that's the arrow. The arrow must not be facing the same direction as this. You can see that these are on the same direction. you can see, look at the direction of the arrow. Why this is what? Is opposing the direction of the three vectors. You can see this is opposing the direction of the three vectors. So this is the resultant. The resultant. Resultant is also what? A vector quantity. Yes, it's a vector quantity. It's a vector quantity. You can see the arrow. That's the resultant of these three vectors. So this is all called polygon. Polygon's what? Polygon's law. Or head to tail method. Head to tail method. Head to tail method. Head to tail method. Okay? That's head to tail method. Head to tail method. Take note. So let's just look at one example under what? Head to tail method. Head to tail method. Head to tail. Head to tail. Head to tail method. Head to tail method. Head to tail method. Head to tail method. So let's go there. What do you have there? If you have head to tail method, let's add 3 units. Let's assume that we have this to be what? 3, okay? With what? Head to tail. This is 4, right? Don't forget that looking at what the direction of the word, the arrow. This is head to tail. Head to tail, that is join the tail of the previous vector to the head, the tail of the second vector to the tail of the second vector to the head of what? The previous what? Vector. Okay? So join the what? The tail of the second vector to the what? To the head of the previous vector. Join them. They won't now be the resultant. Resultant will be what? You draw an arrow from where? A line from where? From the tail of the what? Of the previous vector. You can see. You join tail to tail. Tail to what? To tail of this. The resultant to what? To the tail of the previous vector. And this will give what? The resultant. The resultant. And the resultant is what? The resultant is 5. Don't forget that. Is 5. The resultant is 5. The resultant is 5. Okay? Or you can use your Pythagoras theorem saying that what? Pythagoras rule, that is r squared equals what? 3 squared plus what? Plus 4 squared. That gives what? 16. That gives what? 9 plus 16. That's equals to 25. Okay? So that's r what? R squared. So r will be equals to what? Square root of what? Of 20 what? 5. And that gives what? 5. Meaning that what? This is 5. Okay? That's 5. That's 5. That's 5. That's head to tail what? Head to tail method. Head to tail method. Head to tail method. Head to tail method. Please try this. You can try this and send your answer. Okay? Find the resultant. The resultant. The resultant. The resultant. The resultant between the two vectors. Between the two vectors of magnitude 5 units and 6 what? 6 units. Send your answer. Thank you and God bless you.